At GiantSwarm, we recently finished a large migration as of May from our custom-built Kubernetes cluster management solution to Cluster API, which involved migrating a large number of enterprise production clusters without downtime. And I reckon that might be interesting to some other folks, so I thought I'd present a few things about it. So thanks to KCD UK for letting me do that, and thanks for coming. It'd be sad if I was here alone. I'm going to talk about where we started, how we made our decision to go on this journey, what the migration itself looked like, some fun problems we knew about and some we didn't know about. And then there's some reflection on our overall approach, share some things we learned, and some ideas looking back. As a note, I am going for more of a coherent story than some sort of company archaeology project. So while this might sound straightforward because of the linear nature of PowerPoint, it was a multi-year journey with a lot of iteration and backtracking. And for those of you who've not had the misfortune of meeting me, I'm Joe Salisbury. I work at GiantSwarm as VP Engineering, and at some point in the future, I'll know what that means. Today, my job is talking to you about some of the stuff we've been up to. There are socials, if you're into social media. So let's dig into where we were at before we started this migration. For those of you who've not heard of GiantSwarm before, all these bullet points are true. We build, operate, and manage cloud-native developer platforms for enterprise. We deploy and manage software in customers' accounts. We allow platform teams to focus on differentiating work. The idea is to help platform teams be more successful, or be successful. And towards that, on the product side, this is what our architecture very roughly looked like. It's a high-level view of our Kubernetes as a service product before the migration. And you can think of it as a REST API to CRUD Kubernetes clusters. There's a REST API layer, a sort of operator layer, and then the infrastructure itself. And the operators are the key components here. So for example, the AWS operator, we started in February 2017, so it used TPRs before CRDs. It's a long-going project. And you get one of these sets of boxes installed per cloud region or data center. It's deployed sort of as part of the management system. And if we just look at the data flow, so this is more the AWS case, you have an API, some custom resources, an operator, and then some sort of resources under management. So the REST API creates a cluster custom resource, which describes the desired state of some cluster. The AWS operator reconciling that cluster custom resource into a set of CloudFormation stacks, and those stacks then form the actual Kubernetes clusters. And we'd have the same for other providers with their own provider-specific operator and their own sort of cloud and on-prem resources, or on-prem resources. And topologically, we set this up in a one management cluster to N workload clusters setup. So the management cluster is responsible for managing the infrastructure, and the workload clusters are where customer or user workloads are run. And we'd run one management cluster per cloud region or data center, and then GiantSwarm's running a whole bunch of management clusters. And there's no shared infrastructure between management clusters, so then there's no shared infrastructure between customers. And Cluster API, to move on, this also started in 2017. It's now a fully fledged Kubernetes subproject around having declarative APIs and tooling for provisioning and managing Kubernetes clusters. So users include us at GiantSwarm, but Red Hat, Azure, VMware. And the idea is towards having Kubernetes operators to manage Kubernetes clusters. There's a foreshadowing thing here. And this is the earliest reference to Cluster API that actually Marcus found in the GiantSwarm Slack from when we posted about it in early 2018, just a little bit after it was getting kicked off. So none of these links actually work now, but the second one is interesting around having an early KEP for Cluster API. So talking about having that declarative Kubernetes-style API for managing clusters. And this is the sort of architecture of Cluster API briefly. I've stolen this from their documentation. So you see a sort of numbers of types of controllers, so supporting multiple infrastructure providers or multiple ways to provision Kubernetes, some custom resources, and then a number of providers that they support. I'm not going to go into detail on the architecture of Cluster API or specific controllers. They have really good documentation and there are variable talks. But there are notable similarities in the overall design and feature set. You can put a custom resource in and get a Kubernetes cluster out, but there are some notable differences in architecture. So Cluster API has a different responsibility separation between their shared and what they call infrastructure provider controllers than what we had in GiantSwarm. And they use separate operators for Bootstrap, whereas we had a sort of shared library in GiantSwarm. But topologically, there's a similar layout. This is roughly one management cluster and then you'd have a number of workload clusters. But Cluster API does have some more flexibility in terms of networking and sort of which providers you mix and match. But at a certain point, we realized we were somehow building the same thing. There's a shared basic set of features. There are some features in Cluster API we'd like to have, and some features we'd have to add. But at the least, there's some sort of isomorphism between the two systems. So I'm going to hand wave over a bunch of internal discussion with an emoji of a train. Fun fact, does this emoji look weird to anyone? This is actually the wrong way round. Like most directional emojis go from right to left because they are Japanese. But in most Western cinematography, like an onward direction is left to right. So this I flipped because it felt really weird to me. But I'll move on to the actual talk. At a certain point, we're largely in the understanding that Cluster API, we've made the decision, it would be the way forwards. The major benefits we're looking for were not having to spend as much time developing our own controllers around maintenance or new Kubernetes releases. But there's also an improved feature set and new providers. We reckoned it would take us, in the old system, around 6 months to build out a new provider, and we wanted to improve that and sort of increase agility. And then the question then becomes sort of how to do it. And there's the actual work of getting from the Giant Swarm custom controllers to Cluster API. And just for some jargon, we ended up naming the old legacy product Vintage. I wasn't in the meeting. And we call the new Cluster API product CAPI or Cluster API. I'll use that naming from now on because it's ingrained in my brain and I can't call it legacy. We were running on 3 providers, so AWS, Azure, and what we called KVM, which is a sort of custom bare metal solution that used KVM for nested virtualization. And Cluster API has multiple infrastructure providers, and the naming pattern is CAP wildcard, so Cluster API provider for AWS, Azure, vSphere, and VMware Cloud Director, which is another virtualization product from VMware. And we decided pretty early on that we'd have to perform a managed migration for AWS. We had a large number of clusters, and as a small team, we reckoned that prolonging the time we'd have to maintain both systems would be quite painful. We actually had a breaking change previously on Vintage that was very tough, and we didn't want to repeat it. And we do want to provide as much value to our customer platform teams as we pragmatically can. But we decided for Azure and KVM to not perform a managed migration. We had fewer clusters and customers sort of on and offboarding at reasonable times, and we decided it wasn't worth the investment. So the live migration part covers AWS. I'll sort of implicitly talk about that from now on. With the other providers, as part of the new product line, we built them, new customers created new clusters, and existing customers manually migrated over. And migrating from a sort of home-built KVM virtualization solution to vSphere sounds horrible. So as a fun organizational quirk, early on in the journey, we organized what we called a Hive sprint. The name is really on the nose for Giant Swarm. The aim was to get the company to understand and try out and ideally implement the migration from Vintage to Cluster API. So for one whole month, we suspended our usual teams and meetings, we self-organized new structures, and just all hacked on Cluster API. And we didn't manage to migrate everything in a month. It took a little longer, but it did work well for other reasons. We got the whole organization to understand the future direction. Everyone got in touch and tried things out with Cluster API, and it revealed blockers and issues quite quickly. And it also kickstarted a lot of the larger discussions. We had the larger decisions that we could have space for those discussions for. And then we followed up with them as development kicked further off. We did find, unsurprisingly, that Cluster API wasn't a 100% fit as a replacement when we picked it up. And we also found that different Cluster API providers had different levels of maturity and would then require different levels of investment in terms of development time. So this is one of our GitHub issues where we tracked various work towards productionizing Cluster API for our use case. And a lot of the time between the Hive sprint and the migration itself was spent on product development and integration, which was actually various pieces of work. There isn't any specific large bug fix or intensive feature we had to build. It's stability and security fixes and small features and enterprise requirements. And I like this as an example of how open source projects actually get built with sort of multiple parties collaborating on the project, and it's that hard work of 1,000 features. Let's talk about the actual migration. This is the actual sort of meat of it. We decided to not mix Vintage and Cluster API in the same management cluster. It's more straightforward with like CRD management and organizing our operators. And in the Hive sprint, we had manually proved you could migrate. So when we got to the migration proper, we started building that out into a tool which had the actually creative name of API Migration CLI. And at a very high level, you can understand the migration as moving the vintage workload cluster from the vintage management cluster to the Cluster API management cluster and transforming it from vintage to Cluster API in the process. We did have some other approaches for handling the migration, the CLI, this manual tool. We thought a lot about an operator to sort of more automatically handle it, and then we had some loose ideas around a sort of transparent blue-green cluster migration. We ended up going with the CLI. It was practical with our number of clusters. It was pragmatic and fairly straightforward to develop. The operator, we reckon, would possibly have been overkill. It definitely would have required more development work for complete automation. If we did have like an order of magnitude more clusters, it would have been required, but then the whole project takes longer. With the cluster migration, we explored this least, some sort of rough idea of sort of bringing up a second cluster, transparently migrating workloads, and then bringing it down. We have some customers who have very limited IP address space, like sort of enterprise, so it's just not practical to actually double some of their production clusters. As a fun technical problem, if you work for HashiCorp, you have to legally leave the room at this point. In Vintage, we had built support for using HashiCorp's Vault for PKI, and the provider operators would indirectly talk to Vault to issue certificates, and then we distribute them to workload cluster nodes via Ignition. And we were using like a separate PKI route for each cluster, which has some nice security implications. When we migrated, or when we were going to migrate, we needed to have the same certificate route, otherwise things get weird. It's essentially a new cluster identity. And we did know that we were going to use kubeadm for provisioning the clusters, and you can give it existing certificate material. You can give it a root CA cert and a key. That's all fine. The issue is that Vault won't give you the root CA signing key. There's no API route for it, unless you fork and patch Vault to add an API route that bypasses their security model and will give you the root CA signing key. So at the start of the migration, we replaced Vault with our hacked version and used that to pull the certificate material out. This is those sort of fun, practical things you just have to do in these kind of projects. And to dig into more detail on the actual migration process, I found it best to discuss this in two parts. So this first part relates to the migration of custom resources, and then the second part relates more to the management of the nodes and the resources in the cluster themselves. And the migration tool takes care of these steps. So first, we sort of have to prepare for the migration. We fetch all the cluster custom resources, so those custom resources that represent the infrastructure of the workload cluster from the vintage management cluster. And then we migrate the secrets to the Cluster API management cluster. This is what requires the hacked Vault, which we'd have switched to earlier. And we then stop reconciliation of our old controllers, so they're not trying to sort of reconcile the state of the cluster back. We had a sort of pause annotation for this. So now we can provision the new Cluster API cluster. The CLI can generate the Cluster API cluster, the Cluster API cluster custom resources, say that fast, and we apply them to the Cluster API management cluster. And this is where the Cluster API management starts. So I'll break this down into etcd first, because it's the sort of more complicated part, and then Kubernetes and the control plane and the workers. So the upper section here represents the control plane nodes, and the lower section sort of represents more the etcd cluster, but each vertical slice is equivalent. So with etcd, we started with a vintage HA etcd cluster that runs on the control plane nodes. And then as one Cluster API control plane node starts, that etcd member joins the etcd cluster. Cluster API's etcd management amusingly then removes the old vintage nodes because it doesn't recognize them. And we eventually then remove those nodes themselves. The next two Cluster API control plane nodes start, and they join the etcd cluster. So we end up with a Cluster API HA etcd cluster running on the Cluster API control plane. And the Kubernetes control plane nodes and the Kubernetes workers are somehow symmetrical here. So with the Kubernetes control plane, our CLI tool adds the Cluster API control plane nodes to the vintage ELB as they're becoming ready. So we always have healthy targets. We can always respond to API server requests. And then once we have a Cluster API control plane running, we stop the control plane components on the nodes. We call and drain and delete them. And with the Kubernetes workers, this is probably the most simple part. For each node pool, once new workers come up, we drain the old workers and delete them. And we had some settings in the CLI tool for sort of batch size here for those limited or restricted IP address space environments. And it's a sort of ship of thesis vibe. So you replace all the planks in the boat, and you either have a new boat or the same boat. But either way, we migrated the cluster. And at this point, we end up with the workload cluster entirely replaced and managed by Cluster API. So mission accomplished. It's Churros time. I think it's interesting. Excluding the special cases, so sort of vaults or generating the new Cluster API resources or changing the management cluster, it somehow looks like a regular Kubernetes upgrade. You replace the control plane nodes with new control plane nodes, you replace the worker nodes with new worker nodes. As a note, if you're into it, the networking and DNS of the clusters is actually preserved before and after. We don't touch that during the migration. We're planning on sort of slowly improving and migrating it over time. There's features in Cluster API or Kappa to support this. And the first few migrations, unsurprisingly, did expose issues. And we found we'd also encounter new issues when we started migrating a new customer. So this is the commits over time for our migration CLI tool. So for example, we had a bug where we ended up with different default node sliders between the vintage cluster and the Cluster API cluster, which led to different pods in the same cluster showing the same IP address, which is super exciting when it happens. Exciting is the word. But we had a customer who'd manually changed route tables in vintage. So when Cluster API started managing it, lost all the route tables. And we had a whole bunch of fun when we started migrating clusters in AWS China, because it's AWS China. But generally, we hit a lot of these issues you only see in production or with larger clusters. And I think with the CLI approach, it's fairly straightforward to handle. It just requires the legwork. And we started with a friendly customer, started on lower environments, and sort of took an iterative approach to these migrations. And with the actual migration done for one cluster in a repeatable fashion, the job becomes one of customer management. And I think account management actually takes a lot of the workload here. So this is a screenshot from our calendar for scheduling migrations. And there's a fair degree of customer work here, like enterprises have wild freezes and stakeholder management. With one enterprise customer, they wanted a video call for every cluster migration, and they had a lot of clusters. But thankfully, after migrating a few together, they gained enough trust, and they only joined then for sort of later, higher environments and then their big production clusters. And amusingly, the very last cluster that was scheduled to be migrated ended up actually being deleted by the customer because they realized as they were about to migrate it that they weren't using it. So it was fairly anticlimactic at the end, but somehow more important to have it done. And all migrations were achieved with no data loss and no major production customer workload impact. Very specific wording. Let's talk about some things we might have learned doing all this. So we were juggling much more than just the Cluster API migration during this time. It's several years worth of work. And other migrations are going on at the same time. You can't stop the world. For example, we replaced our custom SSH solution with Teleport. We moved from this REST API to a sort of Kubernetes API-based solution. We built out GitOps support. It's a bunch of stuff. So with my engineering hat on, I want to do one thing at a time, but I think it's not possible even at this sort of large migration, to do it at any realistic scale of company size. And you have to sort of like embrace that and lean into it a little bit more. These slides are all just emojis. I'm sorry about the design. We were initially worried that an upstream solution would slow our pace of development, which would then lead to customer frustration. I think what we'd lent into was that we could do whatever we wanted with the custom-built solution, but that included some sort of bad but quick things. But we ended up having a positive reaction from using a fully upstream solution. So I think the upstream decisions are made with more consensus, they're covering more use cases, it's a more flexible architecture. And we've already seen the benefits of this. Customers have said they've noted smoother upgrades already, so perfect, great. And I think upstream has also turned out to be a source of authority with our customers. So we'll sort of explain upstream's direction and what they're thinking. And that works very well for customers as argumentation. It's not just us, it's the community. And as a personal point, I like open source software. We're thinking more upstream about the company, and that's just personally satisfying. With team topologies at a company level, there's a balance between keeping existing customers happy and working on the new system. So to begin with, we had one team that was working on both Vintage and Cluster API. And given the degree of work for sort of maintaining Vintage with both priorities in the same team, we ended up not developing Cluster API as much as we wanted. So we ended up having to split the team or making the decision to split the team. So one team working on Vintage in a sort of maintenance mode and building that capstone release to launch the migration from, and the other team with the priority to work on Cluster API to get it to a migration-ready state. And I think that's when development really started taking off. I think the learning for me here is you can say what you want to do with your migration, you actually have to make sure your team priorities match, and otherwise it won't happen. We did try to start using so CapG, so Google Cloud, and CapO, so OpenStack, while we were still building out the Cluster API product line, we had some customer interest in those providers. I think we definitely learned a lot about Cluster API and sort of our integration during that, but it was tough and distracted building out from the other products and from the migration as a whole. I think the learning here was to not try and reap the benefits of a migration before you've done the migration. We sort of were a bit too early with that. But we have gotten to a point where new providers aren't particularly scary, so we're a lot further with integrating Cluster API into our product, as well as sort of supporting and bringing up new providers, and it's probably, maybe, depending on who you ask in the company, a matter of weeks to start a new provider now. So for some reason, for example, people aren't as keen on VMware nowadays, so we're investigating Proxmox and Nutanix as providers, or Metal Cubed as a replacement for that sort of bare metal VMware-based providers. And I think the sort of crux, or one of the most interesting questions we had sort of reflectively, was when to replace a custom-built solution with an upstream solution. Because I think very often you can choose an open source project and it'll do exactly what you need, right? You're likely not going to have to add features to Node Exporter, for example. It's fairly feature complete. But I think some of the time, especially with more complex requirements, the project will be close but won't match 100%. And over time, the project will develop and mature, but it's unlikely to magically solve your requirements without your input. And you'll need to do some degree of work, and then the questions become when to do that work, or I think more interestingly, whether your solution is differentiating to customers and will it remain differentiating in the future? So I'm going to, towards the end, really start bringing out large slides. For those of you not aware of Wardley maps, they're a tool for describing value chains. So the x-axis, which is the one that goes across, represents the commoditization of components, and the y-axis represents visibility to the customer. And it's useful thinking about market evolution and sort of decision-making in these kind of spaces. So this is an incredibly simplified map of Giant Swarm's offering. We want to provide internal developer platforms. That's the most visible aspect to the customer. That'll require a cluster management solution. That requires clusters, and that sort of requires sort of generalized compute. And all these components evolve over time. They all move towards the right. Sorry. So for example, Kubernetes clusters are essentially a commodity now. They weren't in the past, right? You have to sort of custom build them previously. Now you use EKS. It's more of a product. And I think we've seen the same thing with cluster management systems. So whereas you needed to custom build them before, they're now more productized. And as your component becomes more commoditized, as it moves further to the right, your methods for building or managing that component should probably change, right? If you're custom building something, you're going to be using agile methods. If it's a commodity, you're probably going to be buying that off the shelf from a vendor. And I think the point where it's more practical to replace, where it is practical to replace a custom-built component with an open-source component is when that component moves from custom-built to product, because in that space, it's more straightforward to have multiple organizations collaborating on shared requirements. You will have had multiple parties who've custom-built that solution and now want to sort of move up the stack and start differentiating. And they can share their learnings in that space. Or to put it another way, much simpler, your company has a limited amount of time to spend on innovation. Don't spend it on products that other people have started becoming interested in building together. So here's another scary looking diagram. I don't understand this, so I'm not going to go into detail. Xavier and Antonio talked about Edge on Kubernetes yesterday. This is basically that. This is an architectural diagram of our hybrid or smart factory or industrial IoT platform. We run a management cluster in the cloud and like a workload cluster in a factory right at the edge using Cluster API. And I think since migrating to Cluster API, we've started being able to build out more functionality on top of our clusters. So this is an example of how we managed to make use of an open source project and then start innovating on top. Don't look at it too hard because it'll give you a headache. So I'll start recapping. We originally started with a custom-built cluster management solution. We then noted that the open source community had solved the same or similar problems, and we made the decision to rebase on top of the open source solution. I think the migration itself was difficult. It required deeply technical work and also sort of leadership buy-in and customer management, and the whole organization was involved. There's definitely second system syndrome. But on reflection, I think it is or can be a very difficult decision to decide on whether and when to replace custom-built solutions with open source. Possibly there's some insights from our decision-making and outcomes we achieve that can help people in future. I think the main note for me is sort of considering how your solutions will commoditize over time and whether they'll be differentiating in future. That's That's the take. Remember that word. This is my last slide. One theme from when I was talking to people in the company, this is just my holidays, to help prepare for this talk. Everyone I spoke to noted that it was very much a team effort from the whole company. So this is me saying thanks to everyone who actually did the real work, so I can stand here and say lots of things that make it sound like I did anything useful. But yeah, I wouldn't be able to talk about this if they hadn't done the real work, so yeah, thanks. And that's all. Those are all my words. If you're on a platform team and you want to do less of this, let's talk. Yes, thank you.
Right.